Right. So next, this what we have here. This is P. Is 2, 3, and then it's 5, 7. This x, y. We want to find the answer. We want to find the coordinate P. But we know the ratio is 2, 3. It's internally dividing. So what we do, how can we get the coordinates? This is the x-axis coordinates. So this will divide here, and this will divide here. The same two have it. So what we can do is, first of all, we can find the length, this length, and compare with this. Okay, let's assume this is this length is, let's say, k, and this is g. Then we can see that length g over well, let's say, let me make it this way so that it becomes very simple for us. You can see length g over length k. That's this length g over length k should be equal to, of course, the same thing. This will come here as j here, and this will come here as k here. The same thing. So this should be equal to, we are only working in the x-axis one. In that sense, then we are going to have x here minus our coordinate here, which is 2. Okay, that is x here minus 2 over that. Then we come to the second half. So this will be x here minus 2 will give us this length. Now let's look at the second length here. The second length here on the y, on the x-axis. Then the second length is going to be what? The same value that we have here. Our second length here is going to be our x here minus our, so our x here is what? 5. Our x here is 5 minus our x here, which is what? That. Okay? Right. So when you get this expression, then you can easily work out to find x. J is given to you as 2, so 2 over k, which is 3, is equal to x minus 2 over 5 minus x. Of course, this is going to give us 2 into bracket 5 minus x. This is going to give us 3 x minus 2. Right? This is going to give us 10 minus 2x is equal to 3x minus 2. Minus 6, sorry. Minus 6. Of course, this will come up here as words. If 2x plus 6 is going to give us 5x. Okay, we are bringing the x on this side. Okay, 5x. And this is plus on this side. This must come 6. That's going to give us 16x. Right. Plus, and this is going to be, this is going to be plus. This is going to be, this portion becomes plus. So 16, and this portion becomes what? Plus, so 16, 15. So x is equal to, divided by 5, so that x is equal to 16 over 5. So the coordinate for 16 over 5 is the same as, I think, 3 point, let's see, 3 whole number, 1 over 5. Yeah. Was 3, 1 over 5. So we go for the coordinate 3, 1 over 5, and that will be the coordinate for x. So that is the coordinate for x. So you will see this works. This ratio that we have for this line, it will apply to the x-axis. Now we can do the same thing for the y-axis. For the y-axis, we use the same ratio, j over k. But this approach may not be shown in other textbooks. But in most textbooks, this is not there, but this works. It works, and it works from first principles, and it makes it very simple for you to get. You find this approach in any book, but like I said, it works out. From my perspective, I think this will be better. You'll be better off dealing with the equation like this, so that you understand it from first principles rather than committing formulas too many. Right. So the same ratio here will be applied. This is k and this is j. So k over k should give us the length. We now want this length. Now the first j length is here to here. So in that case, we have xy for this coordinate. So our y is here, and then we have the xy for the down coordinate here. So that means we are interested in y because we want to find this length and say that length, which is also 2 over that. Okay, so in that case, we're going to have the first point here, the final point minus the initial. So it's going to be our y minus our y, which is 3 here, over, to give it the same ratio. Next, now this our y, we are going to the last point. The last one becomes bigger than this point, so it becomes what? The last point, which is what? 7 minus y. Okay, we can now replace the ratios by that. G becomes what? Our G becomes what? 2 over 3 is equal to y minus 3 over 7 minus y. And this we can solve this equation. We can solve this equation to get the answer for y. So we solve that, and then that will give us the value for y here. Then in that case, we have found x and y. We know x already, found x in this 3 over number 1 over 5. So we got for y and then get that. That will be the coordinate. So you see, this becomes very simple to deal with. And that is one approach you can use. You will not need to commit to memory and then to sort of get an answer. Okay, some formulas we try to make the ratio 1 to another, so that, of course, if you are able to get the formula to find, that's, you just remember the formula and then put it in. But if you understand it from these principles, it will also help you solving other questions which may not demand formulas straight away. Right. So that is the approach. So now let's look at it. Let's look at where we have the external kind of division of the line. See, the same principle can be applied. Yeah. And it works. Okay. Good. So this is it. Let's assume I would prefer to always show on the xy axis so that the points be different. So let's use the same 2, 3 points here, 5, 7 points here. This is our A, this is our B. Now instead of having the line dividing with D internal, it's now external. Let's say P is here. This is P. We want to find the coordinate P. Let's assume here the ratio here, let's say this is 2, and this is, let's make it 3 again. 3 again. Right. So so let's see how it goes. Now this is the point we are interested in. We are saying this line, the point here is what is dividing A and B. That this is an external division. Okay, external division. Now the point is, if this is the point, that is where we are interested in, then A comes here. Okay? Now the first division, and the distance is 2. The ratio is, the length is 2. This length is 2. Now from there, you go to B. And what do you think will be the distance? Will it be 3 or 2? It will become 2 plus 2, this will become 5. So this is 2 and this is 5. So that's the ratio, the length, their length. So that you see that if you want to compare, let's say the length of, if you want to use a ratio, let's say from A to P over P to b. That will be equal to what? A to p is 2, but because we said this, if it is external, it becomes negative. So we're going to have negative 2 over, and then from p to b is what? 5. It's 5. Good. So we count that. And that's how it's going to work. Okay? Then we can, from this, we can now work things out to get the answer. Remember, if p comes to this side, then this is how we're going to get it from a to p. Will be what? Let's assume this is 2. A to p will become 5. Okay? And then from p to b will become 2. So look at it well. So always arrange them in the way you want, the way you want to solve it, or how the person would have been. So in this kind of expression, a to p over p to b will be equal to what? A to p is 5, but because it's negative, it's external, so it will be negative. So it will be 5 over p to b will become 2. So always make sure they go in that pattern. Once you get the pattern, you're able to solve the question. So when you have this is the expression. We are not dealing with this one. We are looking at p from this one. So let me think of that. So this is what you have to know. Now that you have that, we can easily work out the coordinates for p. So we don't know the coordinates for p. This is 5, 7. We need the coordinate for p. We want to find p, which is x, y. So how do we find it? We have been given the ratio in which p divides a and ab, line ab external. Right. So all you need to do, we have already said a to p. A to p. Where's a to p? We are looking at the x-axis part. We are looking for the x coordinates. Yes. So a to p is here. And then we have that is how it's going to be. Because the ratios, you should remember the ratio. This is 2, same thing. Okay, from there to that side, that's going to be our 5. Okay, so that's the ratio. Once you say this one is 2, and then that one is 5, we look at it from that perspective. Right. So using the same principle, then you should be able to work out the coordinates. Right, now, so like we said, so this is an external division. So A to P and P to B. So that's the ratio. A to P is in the negative, moving in the negative direction. And then P to B going in the positive direction. Right. Now, in the same order, you must always remember that we are saying P is the midpoint. Is the midpoint, or is the division, the point that is dividing, or dividing point. Therefore, P must be maintained. So P is the one between, externally between, which is in inverted commas, externally between inverted commas. So we are saying P is in between. So for first one, P is ahead of your first point, which will mean that you have your P point x minus your A point, which is 2. And then the second one, P now comes below it, and this is ahead, so it becomes what, your 5, which is the x coordinate, minus your P point. Okay, so when you have it like that, if you go with the order, so you realize that always, if it starts, it comes here, right? So that if you see this point 2, let's say x here, and this 2 is greater than that. It's greater than x. So when you subtract 3 from that, then of course, you are going to, because 2 is when it's ahead of that will modify the equation. Assuming 1 is x is 1, and it's 1 minus 2, then going to be negative. That is why the first part will become negative, because it's external. The second part, we are assuming P is below the point P. So in that case, if you subtract, it's going to be positive. So that is it. That's going to be the effective P. Fine. Right, so from this expression, you can get your x, you can work and then get your x, so that you have negative 2, 5 minus x is equal to 5 into x minus 2. And this you can work out to get your x value. Right, so in general, just for you to use the formula, if you want to use the formula, the same thing, the principle. So the ratio, let's say ratio 1 over ratio 2, okay, should be such that our x, the point p, minus our x value, and then we have our x, let's say x1, x2, this is the dividing point, minus xp. And this is the ratio in that order, the first ratio, the second ratio. So this is the formula for internal division. For external division, you will negate it. Negative r 1 over r2. Then the same thing happens. x1, x2, xp. Of course, when you are finding the corresponding value, the same thing works for y, the y coordinate. So it will be r 1 over r2 is equal to x, equal to yp minus y1 over y2 minus yp. Okay, so the same thing. So this will be the coordinate. This will also be the coordinate for the other one. It's also going to be. So there is it. I'm also going to have the same thing. Minus r. This is external. This is external division. This is internal. And this is 1 over r2 equal to your yp minus your y1 over y2 minus your yp. Right. So if you do it like that, then you would get your answer as it is. So these are the formulas you can use, and that makes it very simple to be used. Remember, if external is going to be negative, this internal is going to be positive. Of course, look at the order. The order will tell you. Of course, when you are dealing with the external, remember the ratio will not just be between the 2 points. It is with reference. The reference point is the P point. Okay, so the P point. Right. So that in this case, this will not become 3, it's wrong, it will rather become 5. That should be noted. Alright, so that should bring us to the end of the last bit I want to add will be the when you are given two lines, okay, and then you are told an angle between them. You can ask to find the angle between the two. Okay. So that let's say I'm giving these two lines. This is the angle between them. Okay. Line A and line B. So tan of that theta, of course, you look at that in that sense. Right. So let's say this is it. This is M2, this is M1, the gradient M1, gradient M2. Right, so in that case, what you should have, you should note the coordinate very well. So that what you have is M2 minus M1, 1 plus M2 times M1. This is the formula. And use theta or any angle you want to, phi or theta or any angle. So the gradients, if you know the gradient for this one, you know the gradient for that one. Of course, you can use y is equal to mx plus c to find the gradient. So the gradient of, if you know the gradient of the two lines, you can find the angle. So the difference between the gradients, 1 plus the product of the gradients, that will be the answer. Now let's look at also another point. So of course you should remember at this point M2, M1 should not be equal to 1. Okay, should not be equal to negative 1. But if this is negative 1, this will be 0. And to make the equation not defined. Alright, so let's look at sketching graphs. It's important. That is very simple. Before we go to differentiation, I'll just straight away look at it. For instance, if you are given this equation to find y is equal to x squared minus 2 x plus 9, then we ask, of course, once we see x to the power 2, it means the graph is of this kind or that kind. If x to the power 3, then I'm going to have that. X to the power 4 and so on. So usually what you do is, assuming I'm giving this to sketch, the first thing I'll do is I'll have to first find when y is equal to 0. You find y is equal to 0, then you find the value for x. Okay? Then you also make x equal to 0. Then you find the value for y. So when y is equal to 0 is here, so you find, let's say, value for x is here. When x is equal to 0, y is maybe here. So you keep on doing that, okay? Then the gradient is also given by changing y over changing x. So you can differentiate this one. If you differentiate, okay, differentiate this one. At that point, when the gradient, if you do the differentiation of this, you bring back 2x plus what? 2. Okay? The gradient is always at the point of gradient, the turning point. This is the turning point. At the turning point, this divide the x is equal to 0. So if this is equal to 0, you get that 2x is equal to minus 2, and x is equal to minus 1. So you look for x equal to minus 1, x equal to minus 1 is somewhere here. So it gives you the point that, okay, then it means the turning point is around that point. That is where the turning point is. Is it a maximum point or minimum point? For maximum, the 2 divide the x squared. Of course, that is turning like that. Okay. That will give you your positive. Okay, that's the big. If it is this part is giving you your negative. So the second differentiation, if you do the second differentiation, then it's less than 1, then it's negative. Then it's telling you it's a minimum. Okay, and then you can do that to also. We'll come to this problem when we get to the next section. So that all that I'm trying to say is, let me just be brief about it. We'll come to it when we get to the differentiation aspect. So when you are sketching, first make y is equal to 0 and find x value. Make x is equal to 0 and find y value. Okay, then when you have done that, find the y, the x, that is the gradient at which this is equal to 0. Okay, when you find it, equate it to 0, and then you find the value for x. When you have done that, go differentiation to the y, the x squared. Okay, and that point is negative, you know the less than 0. If it's greater than 0, then you note it and then use that one to differentiate. So that will give you either is a minimum point or a maximum point, depending on which way it goes, or a maximum point, or like I said, a minimum point, depending. So when you get to differentiation, I don't want to bother you with the differentiation aspect now, but up to this point, if you get the principle, then when you get there, we'll discuss that. Thank you very much.